This is the Edexcel June 2022 paper 3 higher tier, and it's a calculator paper. Question 1, we have a right angled triangle. We need to work out the value of x. So we're using Pythagoras. We've got 3 lengths in the question. We're using Pythagoras' theorem, which says a squared plus b squared equals c squared. C is always going to be the hypotenuse, the longest side. So we've got x squared and 4 squared added together equals 8.5 squared. So x squared plus 4 squared equals 8.5 squared. We want to get x by itself, so we're going to take 4 squared away from both sides to get x squared by itself. And then we're going to square root to get x by itself. So x is going to be the square root of 8.5 squared minus 4 squared. So we just type into our calculator the square root of 8.5 squared minus 4 squared, which is 15 over 2 or 7.5. So x is 7.5. Question 2. T equals 4m squared minus 11. Work out the value of t when m is negative 3. So we're going to change m into negative 3. So t is 4 times m squared. I'm going to change m into negative 3. Wherever I've got m, I'm going to write brackets and put the number inside. So 4 negative 3's squared minus 11. And I'm just going to type this into the calculator exactly how it looks. So 4 times negative 3 squared minus 11 is 25. If you are doing it step by step, be careful of negative 3 squared. A negative times a negative should be a positive. If you just type negative 3 squared into the calculator, like this, negative 3 squared, it's going to give you negative 9. It thinks you mean take away 3 squared. That's why you have to use brackets around the negative 3, so it knows you're squaring the whole thing, which should give you a positive 9. Part B, make P the subject of the formula. D equals 3P plus 4. So we want P by itself. Let's start by taking 4 away from both sides. So both sides of the equal sign, we take 4 away. So on the left side, we've now got D minus 4. And on the right side, we had plus 4. We took 4 away to get rid of it. We've just got 3P left. Now to get P by itself, at the moment it's multiplied by 3. We do the opposite of multiplying by 3, which is dividing by 3. So divide both sides by 3. We get P is equal to D minus 4 over 3. And that is our answer. Question 3. Rick, Selma and Tony are playing a game of counters. Rick has some counters. Selma has twice as many counters as Rick. Tony has 6 counters less than Selma. In total they have 54, and we need to work out the ratio of the number of counters Rick has to the number of counters Tony has in the form 1 to P, and we're going to work out the value of P. So we're going to need to work out how many counters each of them have got, so we can write it as a ratio. To do that, we're going to form an equation. So Rick has some counters. I'm going to call that R. Selma has twice as many as R. I'm going to call 2R, 2 times R. Tony has 6 less than Selma. Selma's got 2 R's, so Tony has 2 R's, take away 6. And in total, that's 54. So R plus 2 R's plus 2R minus 6 is equal to 54. So I've got 1, 2, 3, 4, 5 R's 5Rs minus 6 is 54. I'm going to solve the equation, so plus 6 to both sides. 5Rs equals 60. Divide both sides by 5. R is equal to 12. So Rick has 12. Selma is 2Rs. 2 times 12 is 24. And Tony has 6 less than Selma. 24 take away 6 is 18. We want the ratio of Rick to Tony. So Rick has 12. Tony has 18. So Rick to Tony is 12 to 18. We want it in the form 1 to P. I can simplify it by dividing by 6. They're both in the 6 times table, which would get me to 2 to 3. But it's not in the form 1 to something, 1 to P. So I have to half them. I want the Rick to be 1, so I half both sides. 1 to 3 over 2, or 1 to 1.5. So the question said, what's P? P is 1.5. Question 4. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of the rolls of wallpaper from each of 2 shops. So Chic Decor, we can get 3 rolls for £36, or Style Papers, 5 rolls is £70, but we've got a 12% off discount. Joe wants to buy the 15 rolls as cheaply as possible. Should Joe buy from Chic Decor or Style Papers? You must show how you get your answer. So we're going to buy 15 rolls, 3 rolls for £36 at Chic Decor. So Chic Decor, 3 rolls for £36. So if I want to buy 15 rolls, I'm going to buy 5 lots of this. And it'll cost 5 times as much. So 15 rolls for, that's £180. We can use a calculator, remember. So 36 times 5 is 180. So 15 rolls cost £180 at Chic Decor. At Style Papers, five rolls are £70, but we've got a 12% discount. So let's work out the price without the discount. It doesn't matter if you take the discount off now or take the discount off at the end, you'll get the same answer. So 5 rolls for £70. If I want 15, I'm going to times by 3. So that will get me 15 rolls for 3 7s are 21, so £210. But I get a 12% discount. So I need to take 12% off of this. So there's a 12% discount. The easiest way to take 12% off, or the quickest way to take 12% off, is 100% take away 12% is 88%. 100 take away 12 is 88. So I want 88% of 210, and I can get that in one calculation by doing 88% times 210. So 0.88 times 210 is £184.80. £184.80. So which is cheaper? So Chic Decor is cheaper. So we should get them from Chic Decor. Question 5. The table gives some information about the lengths in centimeters of some pieces of string. and Amos draws a frequency polygon for this information, write down 2 mistakes that Amos has made. So let's look at Amos's frequency polygon and see what mistakes he's made. So always check the scales. So check they're going up in the same amount every time. And you can see on this vertical scale, there's 40 missing. So 40 is missing. It's jumped straight from 30 to 50. So that's our first mistake. 40 is missing from the vertical scale. And a frequency polygon, we should be plotting the midpoint against the frequency. So 5, 15, 15, 20, 25, 50, and so on. So we've got 5, 15, 25, 35, but the last point has been plotted at 50. So it should be at 45, 5, not 55. And we just write that the last point should be at 45, 5. Question 6. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. So for Amy's average speed, we're going to use speed is distance divided by time. We know the time, we know how long it took Amy, but we don't know her distance, but it's the same distance as Jessica. So we're going to have to work out Jessica's distance. So for Jessica, 15 minutes at 6 miles per hour. Distance is speed times time. So distance is her speed, which is 6 miles per hour, times the time. I don't want to use minutes. I don't want 15 minutes because I've got miles per hour. So really, I want 15 minutes in hours. How much of an hour is 15 minutes? It's a quarter of an hour. It's 15 sixtieths of an hour, which is 1/4 of an hour. So 6 miles per hour for a quarter of an hour, a quarter times 6 is 1.5. So that'd be 1.5 miles. That's the distance 1. The second distance, she then runs 40 minutes at 9 miles per hour. So distance is speed, 9, times time, 40 minutes in hours. 40 sixtieths is the same as 2/3. So 9 times 2/3 is 6 miles. So the total distance, 1.5 plus 6 is 7.5 miles. And that's how far Amy runs. So it's 7.5 miles. So now speed is distance divided by time for Amy. Speed is distance divided by time. So the distance is 7.5 miles. The time is 45 minutes. So 7.5 divided by 45 minutes. But again, 45 sixtieths of an hour is 3/4 of an hour, or 0.75. So 7.5 divided by 0.75 is 10. 10 miles per hour. Question 7. The diagram shows rectangle STUV, TQU, and SRV are straight lines. All measurements are in centimeters. The area of trapezium QUVR, so the shaded area, is A centimeters squared. Show that A is equal to 2x squared plus 20x. So we need to work out in terms of x, we're working out the area of the shaded region. So we could either use the area of a trapezium. We could say area of a trapezium is half the sum of the parallel sides times the distance between them. Or we could split this into two shapes, split it into a triangle and a rectangle, and add them together. So either one of those methods should give us the right answer. Let's have a look. So we know this measurement is 5. Let's split it into two shapes. This must be x, because we've got 3x along the bottom, 2x along the top. The missing part must be another x. And we've got 4x as the height, because it's the same as the other side, because it's a rectangle. So let's just do area of triangle plus area of rectangle. So the area is the area of this triangle. The area of a triangle is half times the base times the height. And the area of a rectangle is just base times height, 5 times 4x. So let's just simplify this. So half times x times 4x. Half times 4 is 2. X times x is x squared. And 5 times 4x is 20x. So we've got 2x squared plus 20x. Question 8. An electricity company charges the same fixed price for each unit of electricity used. David uses this graph to work out the total cost of the electricity he has used. Work out the gradient of the straight line. So gradient, which is called m, is the change in y divided by the change in x. So for each one you go across, how much do you go up or down? So let's find two good points we can use. We'll use 0, 0 and 114. So the change in the y from 0 to 14 is 14. The change in the x from 0 to 100 is 100. So 14 over 100, or 0.14. What does the gradient of the line represent? So it's the cost in pounds and the number of units used. So for every one you go across, how much do you go up? So for every unit you use, how much does it cost? So it's the price per unit. It's 14p for each unit of electricity used. The cost per unit. Question 9. Part A, express the square root of 10 to the power of 360 divided by 10 to the power of 150 times 10 to the power of 90 as a power of 10. So we're going to simplify these indices. When we multiply indices, we add the powers. So I'm going to keep the square root sign for now and the 10 to the power of 360 on top. 10 to the power of 150 times 10 to the power of 90. We add the powers, 150 and 90, is 240. So we've got the square root of 10 to the power of 360 divided by 10 to the power of 240. When we divide indices, we take the powers away. So 360 take away 240 is 120. So we've got the square root of 10 to the power of 120. What is the square root of 10 to the power of 120? What number times itself makes 10 to the power of 120? That's 10 to the power of 60. 10 to the power of 60 times 10 to the power of 60 is 10 to the power of 120. We can also think of this, a square root is the power of a half. So 10 to the power of 120 to the power of a half. When we've got an indice, when we've got a bracket, we times the powers. Half of 120 is 60. So our answer is 10 to the power of 60. Liam was asked to express 12 to the power of 50 squared as a power of 12. Liam wrote 12 to the power of 50 squared is 12 to the power of 50 squared, which is 12 to the power of 2,500. Liam's method is wrong. Explain why. Well, 12 to the power of 50 squared should be 12 to the power of 100. So what's he done wrong? He has done 50 squared. He squared 50. He should have done 50 times 2. He should have done 50 times 2. When you've got a power to another power, when you've got a bracket around the power, you times the powers. So it should be 12 to the power of 100. Question 10. Jane bought a new car 3 years ago. At the end of the first year, the value of the car had decreased by 12.5%. The value of the car then decreased by 10% for each of the next 2 years. At the end of the 3 years, the value of the car was £17,010. Work out the value of the car when Jane bought it. So Jane bought a car for X pounds. In the first year, it decreased by 12.5%. So 100% take away 12.5%. 100 take away 12.5 is 87.5%. So with a decimal, that's 0.875. So to find out the price, the value at the end of the first year, we times by 0.875. It then decreased by 10%. So 100% take away 10% is 90%, or 0.9 for each of the next 2 years. So times 0.9 times 0.9 again. And then after those 3 years, it's worth £17,010. Work out the value of the car 3 years ago. Work out X. So at the moment, X is multiplied by 0.875 and 0.9 squared. So to get X by itself, we're going to divide by 0.875 times 0.9 squared. And I'm just going to type this into the calculator. And we get £24,000. So if you start with 24,000, you take off 12.5%, then you take off 10% in the second year, and then 10% again, you get £17,010. £24,000 is our answer. Question 11. Raheem had 16 shirts, 5 pairs of jeans, 3 jackets. Raheem chooses an outfit to wear with 1 shirt, 1 pair of jeans, 1 jacket. Work out how many different outfits Raheem can choose. So this is the product rule for counting. We're just going to do 16 times 5 times 3. And we get 240. Question 12. ABC and ACD are right-angled triangles. D to C is 8. ADC is 45 degrees. ABC is 20 degrees. We need to work out the length of AB. And we're going to give our answer to 3 significant figures. So let's start with the triangle on the left. We could use trigonometry, SOHCAHTOA, to work out the length of AC. But if you recognize that this is an isosceles triangle, so we've got a 90 and a 45, the other angle must also be 45 degrees. Which means AC is 8 centimeters. So we don't actually have to do any calculations if we recognize that this is an isosceles triangle. If you didn't, it will be no problem. If you use SOHCAHTOA and worked it out, you'd get the same answer of 8 centimeters. Now for our triangle ABC, we are going to use SOHCAHTOA. So we've got the hypotenuse that we're working out, the opposite, which is 8 centimeters. The adjacent, we're not going to use. The adjacent's not in the question. So are we using SO, CA, or TOA? O and H, the ones with not A, it's SO. And SO means sine theta, sine with the angle, is O divided by H. Our angle's 20. So sine 20 is 8 divided by H, which is X. We want to solve for X now. So I don't want the fraction. I want to get rid of the fraction. I'm going to do that by multiplying by X. So X times sine 20 equals 8. And then to get X by itself, divide by sine 20. So 8 divided by sine 20. 8 divided by sine 20 is 23.4. So X is 23.4 centimeters. Question 13. A and B are vectors such that A is 2, negative 3, 2 right, 3 down, and 3a minus 2b is 8, negative 17. So 8 to the right and 17 down. Find b as a column vector. So 3a's take away 2b's is 8, negative 17. So 3 of these a's minus 2b's equal 8, negative 17. So we're going to work out what b is. It's just like solving an equation. So let's work out what 3 a's are worth. So 3 lots of a will be 6 to the right and 9 down. 6, negative 9. So 6, negative 9 minus 2b equals 8, negative 17. I'm going to add 2b to both sides. I don't really want negative 2b. I want to make it positive, so I'm going to add it to both sides. So I get 6 negative 9 equals 8 negative 17 plus 2b. Then I'm going to take 8 negative 17 away from both sides. So 6 negative 9, take away 8 negative 17 equals 2b. So I can just take these vectors away. Take away the x's and take away the y's. 6 take away 8 is negative 2. Negative 9 take away negative 17. So a negative 9 take away a negative 17. If you take away a negative, you actually add. So negative 9 plus 17 is 8. So negative 2, 8 is 2 lots of b. So to find 1b, we half it. So negative 1, 4 is b. Question 14. Factorize fully 4p squared minus 36. So firstly, we could take 4 out. So 4 can come on the outside. We'll have 4, and then 4 times p squared makes 4p squared, and 4 times negative 9 makes negative 36. We're not finished because we could factorize that bracket again. We've got the difference of 2 squares. We've got p squared minus 3 squared, p squared minus 9. So p squared minus 9 can be written as p plus 3 times p minus 3. So we have 4 times p plus 3 times p minus 3. Part B, show that m plus 4 times 2m minus 5 times 3m plus 1 can be written in the form am cubed plus bm squared plus cm plus d, where a, b, c and d are integers. So we're expanding these triple brackets. So I'm going to expand the first two and leave the last one alone to start with. So m times 2m is 2m squared. M times negative 5, negative 5m. 4 times 2m is 8m. And 4 negative 5s are negative 20. And it's still multiplied by the last bracket, the third bracket, 3m plus 1. I can simplify the first bracket before I expand again. Minus 5m plus 8m is 3m. So 2m squared plus 3m minus 20 times 3m plus 1. Now I'm going to expand again. I'm going to multiply the 3 terms, each of these 3 terms, in the first bracket by both of the terms in the second bracket. So 2m squared times both the terms, 3m times both the terms, and minus 20 times both of these terms. 2m squared times 3m, 2 times 3 is 6, m squared times m is m cubed, 2m squared times 1 is 2m squared. 3m times 3m is 9m squared. 3m times 1 is 3m. Minus 20 times 3m is minus 60m. And minus 20 times 1 is minus 20. So simplifying, collecting the like terms, I've only got one m cubed term. So I've got 6m cubed. I've got 2m squared plus 9m squared, which is 11m squared. I've got 3m minus 60m, which is minus 57m. And I've just got minus 20 on the end. So that is fully simplified. It's in the form we were asked to give it in. So that is our answer. Question 15. P, Q, R and S are 4 points on a circle. PXR and SXQ are straight lines. We can see that from the diagram. prove that triangle PQX and triangle SRX are similar. So if they're similar, that means all the angles are equal. So to prove that two triangles are similar, we need to get angle, angle, angle. So let's start with this angle here. So PXQ is equal to SXR. They are opposite angles. Opposite angles are equal. How about the other angles? So angles in the same segment are equal. So we could draw a line from Q to R and split the circle into two segments. Any angles that come off of this chord from these points, Q and R, are equal. So if I drew any angle from these 2 points, they would be equal. Any angles in this segment are equal. So angles in the same segment are equal. So we can say XSR and XPQ, XSR equals XPQ, angles in the same segment are equal. And we can give the same reason for PQX and XRS. PQS equals XRS. Again, because angles in the same segment are equal. So we have all three angles are equal. They've all got a green one, a blue one, and a purple one. So we've got angle, 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 therefore similar. Question 16. P equals the square root of 2e divided by f, and e is 6.8, correct to 1 decimal place. So we're going to have a bounds question. F is 0.05, correct to 1 significant figure. Work out the upper bound for P. Give your answer to 3 significant figures. So let's look at what E could be and what F could be. So for E, it's 6.8 to 1 decimal place. So the one down is 6.7. The one up is 6.9. So the lower bound is halfway between 6.7 and 6.8, which is 6.75. The upper bound is halfway between 6.8 and 6.9, which is 6.85. For F, we have 0.05. The one down is 0.04. The one up is 0.06. So the lower bound is 0.045. And the upper bound, halfway again, 0.055. So we're working out the upper bound for P. So the upper bound for P, when we want a bigger number, we want to get the biggest possible E, but the smallest possible f, because when you're dividing by a smaller number, you get a bigger answer. So it's the square root of 2 times the upper value for e divided by the lower value, the lower bound for f. So that's the square root of 2 times upper e, 6.85, divided by lower f, 0.045. So let's just type this in the calculator. So we've got the square root of 2 times 6.85 divided by 0.045, and we have 17.448 and so on. Give your answer to 3 significant figures, 17.4. Question 17. The table gives information about the distances in miles that some Year 10 students live from school. And we need to draw a histogram for this information. So for a histogram, the area is represented. The area shows the frequency. So we're going to have frequency density on the vertical axes. Frequency density can be found by doing frequency dividing by the class width, so how wide the bar is. So frequency divided by 1 for the first one, so 90 divided by 1 is 90. The second bar has got a width of 0.5. 1 to 1.5 is 0.5. It's going to have a base of 0.5. Frequency divided by class width, 48 divided by 0.5 will give us 96. Again, we've got 0.5 as the width for the third bar. 22 divided by 0.5 is 44. 2 to 3 is 1 wide. 8 divided by 1 is 8. 3 to 5 is 2. It's going to have a base of 2. 12 divided by 2 is 6. So then we just need to draw them on. We need to do a scale first. So we can't do 10, 20, 30, 40, 50 because it won't be high enough. So it's 20, 40, 60, 80, 100. So our first bar is 1 wide and 90 tall. So it's got an area of 90. It's 1 wide and it goes up to 90. Our second bar goes from 1 to 1.5, so it's 0.5 wide and it's got a frequency density of 96. So 1 to 1.5 bar goes up to 96. (1.5 to 2 goes up to 44. 2 to 3 goes up 8. And 3 to 5 goes up 6. So there is our histogram. Bar. The histogram below shows information about the distances in miles that some Year 11 students live from school. The number of Year 11 students who live between 1 and 2 miles is n. find an expression in terms of n for the number of year 11 students who live between 3 and 5 miles. So we have an area of n, a frequency of n, a width of 1, so we can work out the frequency density in terms of n. So frequency density is frequency divided by class width, n divided by 1 is n. And then we can just fill in the scale for this vertical axis. We've got n, 2 every 15 small squares is an n. So we've got n, 3n up 1, 2, 3 more, and so on. We're only interested in this 3 to 5 bar though. So we've got a third of n and 2/3 of n, and then we'll have 4/3 of n, and so on. So this bar is 3 tall. So how tall is it in terms of n? So it's 3 tall. 15 squares are an n. We want 3, so it's 3/15. 3/15 of an n. 3/15 of an n. Or we could even simplify that to 1/5. It's 1/5 as tall as this block. So 1/5 of n. And we want the area, so it's the height times the base. The base is 2. The height is 1/5 n. So 2 times 1/5 n is 2/5 n. So the area of the bar is 2/5 n. Question 18. Here is a prism ABC SPQR. The base ABCD of the prism is a square of side 14 centimeters. T is the point on BC such that B to T to C is 4 to 3. So we've got 4/7 and 3/7. But we know the length's 14. So 14 divided by 7 is 2. So each part's worth 2. So B to T is 8 centimeters and T to C is 6 centimeters. The cross section of the prism is in the shape of a trapezium, area 147 centimeters squared, and C to R is 12. So we can work out S to D. So we've got a trapezium. And we know the base is 14. C to R is 12. We don't know this side, which is SD or DS. And the area is 147. So the area of trapezium is half the sum of the parallel sides, which is these two. So half of, let's call it x instead, half of x plus 12 times 14 equals 147. So if we do 147 divided by 14, and then times 2, that's 21. So x plus 12 is 21. Take away 12 from both sides, and we get x is 9. So D to S is 9 centimeters. We need to find the size of the angle between the line ST, which is this dotted line here, and the base ABCD. So that angle and the base. So we can draw on a right angled triangle here. And we're working out between ST and the base. So this is our unknown angle. We've got a right angle here. So we can use SOHCAHTOA. We only know one length at the moment, but we can use another right angled triangle, DCT, to work out D to T. So DCT, DCT, so it's DCT, and we've got 14 and 6. So we can use Pythagoras. So y squared is equal to 14 squared plus 6 squared. So to get y by itself, we square root. So it's the square root of 14 squared plus 6 squared. 2 root 58 or 15.23. So 15.23. So that's D to T, 15.23. Now we can use SOHCAHTOA for this right angle triangle and find the angle. So I'll draw another right angle triangle. We're finding this angle down here. The opposite is 9. The adjacent is 15.23. And we want to find the angle. So we've got the opposite and the adjacent. We're not using the hypotenuse. So it's not SOH or CA. It's tan, it's TOA. So tan with the angle is O divided by A, 9 over 15.23. To get theta by itself, we do the opposite of tan, which is shift tan, arctan. So we just type that in the calculator, shift tan of 9 divided by our last answer, which was 15.23, press equals, and we get 30.6 degrees. Question 19. Show that 3x over x plus 2 minus 2x plus 1 over x minus 2 minus 1 can be written in the form ax plus b over x squared minus 4, where a and b are integers. So here we're taking away fractions, and to take away fractions, we need the denominators to be the same. So that's what we're going to do here. We're going to make the denominators the same. So for our first fraction, we've got 3x over x plus 2. We're going to make the denominator x plus 2 times x minus 2. So if we multiply the bottom by x minus 2, we need to multiply the top by x minus 2 as well. For our second fraction, we're going to multiply the bottom by x plus 2. So we're going to multiply the top by x plus 2 as well. And for the 1, we're going to change it. So at the moment we've got 1 over 1. To get the denominators the same, we need to times top and bottom by x plus 2 times x minus 2. So now we've got the denominators the same. It doesn't matter that I've written x plus 2 times x minus 2 or x minus 2 times x plus 2. They are the same thing. It doesn't matter which way around the brackets are. It just means they're multiplied together. So now I can make them into one fraction. So I can write it all over x plus 2 times x minus 2. And I'm going to expand the brackets as well. So 3x times x, 3x squared. 3x times negative 2 is minus 6x. I'm going to write minus, and I'm going to keep the brackets. Well, keep a set of brackets when I expand this, because I've got to take all of it away. I don't want to just take away the first term. I want to take all of it away. So 2x times x is 2x squared. 2x times 2 is 4x. 1x is x. And 1 times 2 is 2. And then the last bracket. Again, I'm going to keep a set of brackets. X times x is x squared. X times negative 2 is minus 2x. X times 2 is 2x. And 2 negative 2's are minus 4. I'm going to get rid of these brackets now. So when you take away a bracket, it's like multiplying everything by -1. It's like multiplying every term by -1. It's just going to change the sign of every term. So all positives are going to become negatives, and any negatives will become positives. So I have 3x squared minus 6x minus 2x squared minus 4x minus x minus 2 minus x squared plus 2x minus 2x plus 4 all over x plus 2 times x minus 2. Now I'm going to collect the like terms. So for x squareds, I've got 3 x squareds, take away 2x squareds, take away another x squared, which is no x squareds. So I've got no x squareds. I've got minus 6x, take away 4x, which is minus 10x, minus another one, minus 11, and then plus 2 and minus 2 does nothing. So I've got minus 11. So I've got minus 11 x's. And I've got minus 2 plus 4, which is plus 2, over x plus 2 times x minus 2. I need to expand these brackets, and it is the difference of two squares. So x plus 2 times x minus 2 should give us x squared minus 4. X times x is x squared, and then we get minus 2x and plus 2x, which cancel out, and then minus 4. So there is our simplified fraction, and it's in the form we wanted, so that is our answer. Question 20. The profit made by a shop increases each year. The profit made by the shop in year N is P N pounds. Given that the profit made by the shop next year is Pn plus 1, and Pn plus 1 is A times Pn plus 800, where A is a constant. So the profit in the next year is something times this year's profit plus 800. And we've been given the profit in 2018 and 2019. Work out the profit predicted in 2021. So we can work out what A is. So the profit in 2019 is A times the profit in 2018 plus £800. So the next year is A times this year plus 800. And we know the profit in 2019 is 29,600. We know the profit in 2018 is 24,000. So we can work out A. So take 800 away from both sides is 28,800. So that is 24,000 A's divide by 24,000. So A is 1.2. So now we've got our formula. So the profit in 2020 will be 1.2 times the profit in 2019 plus 800. And we know the profit in 2019 was 29,600. So we can work out the profit in 2020 and then do the same again for 2021. So I'm going to put that as my answer so I can use the A and S button. So I've got 1.2 times my answer plus 800. So I get 36,320. So 2021 is 1.2 times the profit in 2020 plus 800. So 1.2 times my answer plus 800 is 44,384. Question 21. Ray has 9 cards numbered 1 to 9. Ray takes at random 3 of these cards. He works out the sum of the numbers and records the result. Work out the probability that he gets an even number. So he's going to add the cards together and he's going to get an even number. So how can he get an even number? He can get an even by doing, well, 3 evens. Even plus even plus even. But he could also get it by doing 2 odds and an even. So we could do odd, odd, even, or odd, then even, then odd again. So even, then odd, then odd. So they're the only ways we can get an even sum. So let's just work out these probabilities. So the chance of getting an even from our first go, there are 1, 2, 3, 4 evens out of 9 in total. If we've taken an even, if we took one off, our second pick, there's 3 evens left out of 8 in total. And for our third pick, if we've taken out 2 evens, there's 2 left out of 7 in total. So we've got 4/9 times 3/8 times 2/7, which I've got as 1/21. So that's the probability of getting even, even, even. How about odd, then even? So the chance of getting an odd first is 5 out of 9. Then if I take an odd, the chance of getting another odd, there's 4 left out of 8. And then even, there's still all 4 evens left out of 7. So 5/9 times 4/8 times 4/7 is 10/63. And then odd, even, odd, that'll be 5/9 for the first odd, and then 4/8 for an even, and then there's 4 odds left, so 4/7. And you can see this is the same calculation, exactly the same calculation. It'll be 10/63. Even, odd, odd. Again, it's the same calculation, but slightly in a slightly different order. So the even is 4/9. And then if I've taken an even, there's still 5 odds left out of 8 in total. And then the last pick for an odd, 4 odds left out of 7 in total. So when we multiply fractions, we times along the top, times along the bottom. We're still doing 5 times 4 times 4 on top, times 9 times 8 times 7 on the bottom. It's going to be 10 over 63 again. So these are our options. So to get the probability of an even, we add them together. So 3 lots of 10 over 63 plus 1 over 21. So 3 lots of that plus 1 over 21 is 11 over 21. Question 22. L is the straight line with equation y equals 2x minus 5. C is a graph with equation y squared equals 6x squared minus 25x minus 8. Using algebra, find the coordinates of the points of intersection of L and C. So when we have two graphs intersecting, we can find that point using simultaneous equations. So we have to solve these simultaneously. We're going to solve it using substitution. So we're going to take 2x minus 5 and substitute it in for y. So we're going to change the y in the second equation into 2x minus 5. So we've got 2x minus 5 squared equals 6x squared minus 25x minus 8. So we've just got an equation with x's in, and we need to solve it. It's going to be a quadratic, and we're going to solve it to find the possible x coordinates, and then we'll substitute them back into the straight line equation and find the y coordinates as well. So let's expand these brackets first. So 2x minus 5 squared means 2x minus 5 times 2x minus 5. I'm going to expand and simplify. So 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. Negative 5 times 2x is negative 10x again. And a negative times a negative is positive. 5 5s are 25. I'm going to simplify this. So minus 10x minus another 10x is minus 20x. So 4x squared minus 20x plus 25 equals 6x squared minus 25x minus 8. I've got a quadratic here. To solve it, I need to make it equal to 0. I'm going to bring all of the terms over to the right side because I want my x squared term to be positive. So I'm going to take 4x away from both sides. 6x squared, take away 4x squared, is 2x squared. I'm going to plus 20x onto both sides. So minus 25x plus 20x is minus 5x. And I'm going to take 25 away from both sides. Negative 8, take away 25 is negative 33. I'm going to solve this equation. My options are, I could try and factorize it. I'm not sure if it factorizes. It might not. If not, I could use the quadratic formula. So I might try and factorize it and see if we get anywhere. So I'm going to do a times c, 2 33s, or 2 negative 33s, is negative 66. What multiplies to make 66? I can do 1 66, 2 33s, 3 22s. I can't do 4 or 5. I can do 6 times 11. 6 and 11 can give me a negative 5. So I think it will factorize. So I've got 2x squareds. I want minus 5x. So I'm going to do plus 6x minus 11x minus 33. So I'm going to put it into brackets now. So what can I take out of the first two terms? 2 and 6, I can take a 2 out. And x squared and x, I can take an x out. So my first term, 2x squared, comes from 2x times something. 2x times x makes 2x squared. 2x times something is 6x. That must be 3. Negative 11x is something times x. That must be negative 11. And negative 11 times 3 is negative 33. So x is 11 over 2, or 5.5. That's what makes the first bracket 0, or negative 3. So there are x coordinates. We need to find our y coordinates. So we'll substitute into y equals 2x minus 5. Y equals 2x minus 5. So we've got 2 5.5s minus 5, which is 6. Or we've got 2 negative 3s minus 5, which is negative 11. So our coordinates are 5.56 and negative 3, negative 11.